Okay, good morning, everyone. Sorry for making you wait. Hopefully, everybody finished their do now. And today, we're going to talk about properties of addition and multiplication. Okay, actually, we learned all properties. I just want to show you the big picture, or kind of assume that it's kind of review for all properties that we will do today. And there are two IXLs. It looks like as a number, it's a lot, but it's very easy practices. Okay, so R9 and R10. So let's move on. And today's objective is I can practice identifying properties of addition and multiplication in expressions. On the next slide, so this is the first kind of IX practice that you will do today. The first one is about identifying the factors of a number versus an expression. So on these first examples, on the left side, there are only numbers. So how could you find out the factors for numbers? For example, 6, you can rewrite it as a 2 times 3, right? So I'm going to use this time times as a dot. So this is a means times. So the factors of 6 is actually 2 and 3, okay? So for 12, so there are 2, 2, and 3. So the factors of 12 would be 2, 2, or 3. Or sometimes there could be another factors of 12. For example, 4 times 3, right? Or there is another factor, which is a 6 times 2. So there are 3 different ways you can rewrite 12 as a 2 times 2 times 3, or 4 times 3, or 6 times 2. All the numbers that you're multiplying with each other, we call those numbers as a factors of the number, given number. Okay, for the last one, it's a 69, and that could be, it's a 3 times, let me think about what number that might be. It's a 20. It's a 23, right? Am I right? 3 times 3 is 9, 2 times 3 is 6. Yes. So the 3 and 23, those are factors of 69. So this is the factors for numbers. And there is also factors for variables and expressions, I mean. So these are all of them are terms, okay? So 13p is actually, it's the meaning of 13p, it's a 13 times p, okay, number multiplied with letter, but we're not putting a multiplication sign when we multiply number with letter. So 13 and p, those are factors of 13p, okay? And for this one, it's a lot, looks like a lot. It's a 12 times x times y and times z. So in here, there are a lot of factors for this term, which is 12 is a factor for this term, x is a factor for this term, y is a factor of this term, and z is a factor for this term, okay? And the last one is, it looks like this time the factors are an expression. For example, it's a 14 times, I'm going to put multiplying sign, and the factors would be this time u plus 1, okay? So 14, it's a factor of this expression, and u plus 1, it's a factor of this expression, because those are the product, 14 times and together. Okay? So let's move on. This is the one practice that you will do today in not intervention, I apologize, for the IXL assignment for today. And the next one, it's about properties for addition and multiplication. So I put every properties that you learned during this unit and from other units. So these are the 4 different kind of properties that you learned until today. The first one is actually commutative property. It's the same thing for addition and multiplication. The only thing is change it, it's the sign. So actually the commutative property, it's a switching order. For example, 7 plus 2, it's the same thing with 2 plus 7. You're going to end up the same result. It doesn't matter if you switch the order. And it's the same thing for multiplication. 7 times 2, it's the same thing with 2 times 7. Both of them are equal 14. So we call the first property commutative property for addition and commutative property for multiplication. It's the same thing. Switching order doesn't change the result. The second property that we learned, it's about associative property. Associative property, it's actually switching the parentheses. Okay, switching means rearranging. So if you see in this example, when you have 3 different numbers, if you add them up, like it doesn't matter which 2 you add together. So for example, 1 plus 4 is 5, plus 3 it's a 8, and you can get the 8 on the other way, like 4 plus 3, it's a 7 plus 1, and still 8. So switching the parentheses or rearranging the parentheses, you ended up with the same result, and we call that property associative property. It's the same thing for multiplication. When you multiply 3 different numbers, like 1 times 4 times 3, it doesn't matter which two you start. You're starting with multiplying. So 1 times 4, it's a 4. 4 times 3 is 12. Or you can do first 4 times 3, it's 12, and times 1, it's still 12. It doesn't change the result. Okay. So the second property that we learned is associative property. The last one, and that it's a very obvious, we talk about a lot of opposite of numbers in this one, and we call that identity property. So for addition, identity property, it's actually here's the definition is this one. Any number, I picked the 4 in here, any number when you add with 0, the result is itself. So that's the identity property, and identity would be 0 for addition. Okay, identity would be 0 for addition. And very similar way, identity property for multiplication, here's the thing. Any number, when you multiply with 1, it's always equal itself, okay? So the 1 will be the identity for multiplication. So any number, when you multiply it 1, it's always itself. And so the other way you can say, any number, when you add with its opposite, it's always 0, means identity for addition, okay? This is the second way you can say it. And for the multiplication, any number, when you multiply with its reciprocal, if you guys remember that word, reciprocal means writing the number over 1. Any number, when we multiply with its reciprocal, it's always equal 1, which is identity for multiplication. Okay. The last thing, it's a distributive property we talk about a lot, and we still talk about later. I gave the basic example in this one. Distributive is actually distributing the number inside of parentheses, like multiplying the number outside of parentheses with every single thing inside of parentheses. This is the last one, okay? So it's a 4 plus 3, it's a 7. 7 times 2, it's a 14. It's the same thing if you do like 2 times 4, which is 8, and 2 times 3, it's 6. 8 plus 6, it's still 14. It doesn't change the result. Okay, so the last one is the distributive property that you guys learned. So these two slides, the first slide and this slide, it's the similar questions that you will see in your IXL practices. All right, and before you start on your IXL, I'm going to review these two skills on a benchmark type question. So this is the kind of question that you will see in your benchmark. Why do we need those properties? The properties is actually tells you what steps you're taking when you do math. So in this example, it says the expression below was simplified using 2 properties of operations. So we need to figure out which 2 properties they are. So for example, the step 1 is actually like moving this line to this line. This is the step 1. Okay. Step 2 is actually moving this line to this line. What property they applied? And the last one is step 3 is moving the previous line to the last line. Okay, so now let's talk about the first step. So I'm going to put 1 inside of parentheses, and if you see like when somebody wrote it down with this line to second line, if you pay attention closely, they switched the order with 29 and 6. So hold on, let me use a different color. So 29 is a red, and for the 6Z, it's this one, and it's right here. So they switched the order. Switching the order means what? If you guys remember, switching order doesn't change the result, and we called it, it's a commutative, property. So the step 1 is a commutative property, okay? So in the step 2, okay, awesome. Step 2, what is this step 2 that it's been done? Step 2 is actually, it's not a property, but you still can tell the action, which action they took it. So step 2, I'm going to write it down too, means they simplified something. So they combined Z terms, as you see, like 11Z plus 6Z, it became 17Z. So it's not a property, but it's still action that you took an action in math. So we call it combining like terms. So this is the very important thing that you need to know. What is a like term? It's actually the terms that has the same variable. Okay, combining like terms. And the last one, so let's talk about the step 3 now. So step 3, let's pay attention this one. From this line to last line, what did they do? So if you see, there was a parentheses, and outside of parentheses there is a number 5. It looks like on the next line it disappeared. Actually, it didn't disappear. It distributed with every single thing inside of parentheses. Distributing means multiplied. For example, 5 times 17, it becomes 85. You can double check if you're not sure. And 5 times 29, it becomes 145. And the last step, it's distributive property. Distributive property. Okay, so this is the kind of questions you may see in your benchmark. You're going to see a student did a job like this, and you need to determine which 2 properties are applied in this example. Okay, so step 1 to step 3 respectfully. So respectfully means step 1 is a commutative. Step 2, it's not a property, but it did combining like terms. The last one is a distributive property. Okay, so this is why we need to know about properties. Okay. And now this is the end of the instruction. So I'm not going to do too much teaching because most of them are review from other weeks, other lessons. Now it's time you guys to practice on your IXLs. If you go on the next slide, there is a 2 IXLs, which is R9 and R. Oops, this is supposed to be R10. Okay. So R10, R9 and R10. If you click this links, it will take you to those practices. And some of the students told me that they finished, which is awesome. But if you didn't finish, I think this is the time that you guys can do it, because we have around 20 minutes that we can finish up these practices, okay? So